Hello friends, welcome back to the channel. In this video we are going to use OSPF dynamic routing protocol to configure a network. With OSPF you can divide the network into multiple areas, but for this video we are going to use the whole network as one area, that is area 0. But later we will be configuring the network with 2 areas and 3 areas. So let's start. So first of all, OSPF, that is Open Shortest Path First algorithm, based upon link state routing algorithm, where every router contains the information of every domain and based upon that it determines the shortest path. Now where does this information come to routers? This information comes to area border routers from the area border routers of other domain that contains all the information and exchange with each other to determine the shortest path. Now for this OSPF we will be using the wildcard mask for configuration, where we can say that this is inverted subnet mask, but for the network configuration we will be using the same subnet mask. So what is inverted subnet mask? For example, for class A addressing, the subnet mask is 255.0.0.0, where the binary representation for that can be this. If you invert all zeros to 1 and ones to 0, you will get the wildcard mask as this. And in decimal notation it can be represented like this: 0.255.255.255. So this is the wildcard mask for class A addressing, and for our example we are going to use the same class for addressing, but with the similar method you can calculate the subnet mask for class B, class C addressing, and also for the class C addressing. So here I am going to use 3 networks, each with one host. You can use multiple hosts in a network or router connected to multiple networks, but just to keep the thing simple I am just using one host per network, and the network IDs I am going to assign as 10. Class A addressing, for this network ID is 20, for this network ID is 30, and for this network, this is also a network ID is 40, and here the network ID is 50. Okay, so this is your 4th network, because every router combination comprise a different network, and this is your 5th network. Now these are the network IDs that I am going to use for every first host. Every first host in the network I am using the host ID as 1.1.1. okay, and for every other IP address of the network I am going to use 1.1.2. okay, so this is the pattern that I am going to follow. So for the first network, the network or the complete IP address is 10.1.1, and the gateway, as we need to define the gateway for every network to communicate via router, means to configure the router. So gateway for this network is 1.1.2. okay, the network ID is same. So similarly here also the IP address is 20.1.1.1, and the gateway is going to be 20.1.1.2. okay. Similarly for the third network the gateway would be 30.1.1.2. okay. So this we will be configuring in the Cisco packet tracer. So for this connection, means router must be configured for every connected port. So here for this connection I am not going to use gateway. Gateway comprises of networks only. okay, so for this connection we will be assigning the IP addresses to these ports. So here the IP address, being this as the first host, will be assigned with 40.1.1.1, and here for this corner 40.1.1.2. okay. Similarly for this network, as this is a separate network, 50.1.1.1, and this is 50.1.1.2. okay. So we will be configuring the network with these addresses. You can take a screenshot of this and configure the network parallelly. Now next task is to divide the network into multiple areas. That is obviously a virtual division, and we just write the command for this division to represent or configure the network with these divisions. So for this video I am going to use only one area, so there is no further division. We are considering the whole network as one area. Next task is to configure the routers. So we need to configure the routers for their directly connected network. So let's just first quickly configure the routers, then we will move to the routing parts. So here I have already added some labels and the nodes of the network. So just make the remaining connections. So here I am going to connect every network from the switch to fast Ethernet 1/1, and to router side I am making the use of fast Ethernet 0/0. So this is also fast Ethernet 0/0. If you are unaware of the labels, then you can simply set the preferences on to show the or to display the labels of the connections. So here this is fast Ethernet 0/0. Let's just quickly see the host one by one and configure their network. So for first host of the first network or the network 10, the IP address is 10.1.1 and the gateway is 10.1.1.2. Okay, so that we have already decided. Now for the router of this network, we need to configure it with fast Ethernet 0/0. Turn this connection on and add the gateway 10.1.2. Done. So this router is configured for this network. Still it is taking time to boot. As you can see, the dots are red. So let's configure the host of the second network. So here the IP address is 20.1.1 as we already discussed, and the gateway is 20.1.1.2. Now the router of this network, for fast Ethernet 0/0, turn it on and add the gateway of the network. Sorry, this time 20.1.1.2, and done. So the second router is, or router 1 is also configured. For third host, you can see the IP address as 30.1.1.1 and this is the gateway .2. Now for router, simply turn the fast Ethernet 0/0 port on. This interface is on now for the connection, and add the gateway of the network that we have decided as 30.1.1.2. Done. So all the three routers are configured, labeled from 0 to 2, router 0, 1 and router 2. Now it is still taking some time. By the time we can make the connections of the routers. So for this I am using serial 2/0 for this network 40, and this side also I am using the same port. Okay, I am keeping the same serial port for one connection. So here serial 3/0. So here as I have both the options, but I am connecting it to serial 3/0. Okay, so this is serial 2/0, this is serial 2/0, 3/0. So here let's check whether the hosts are connected or not. Yes, the connections are okay for the second host of the second network. Done. Let's quickly check for the third network. Done. So all the connections are okay for the host to router, but we need to configure the router for these connected ports as well. So let's start. As it is connected to serial 2/0, this is the configuration of router 0, means the first router labeled router 0. So turn it on. Now for being the first host of network 40, it is assigned with the IP address 40.1.1.1. Done. Now it's turn for router 1. So router 1 is having two more connections. So serial 2/0, turn it on, and as it is a part of network 40, so it will be assigned with the IP address of network 40, that is 40.1.1.2. Done. Now it is also connected to network 50, and I am taking it as the first host of the network 50. So I am assigning it with the IP address 50.1.1.1. So you may assign any other IP address of a different network. So I am using this pattern. So for the third router or router labeled router 2, for serial 3/0, it is having only one connection to the router, serial 3/0, turn it on, and as it is the second host of the network 50, so IP address is 50.1.1.2. Done. So routers are configured for their neighboring networks, neighboring routers, not the networks. So here from router 0 to router 1, status is successful, means packet data unit is delivered successfully. Now router 2 to router 1, again we got the success, right? So now let's check for the router 0 connection with router 2. Okay, so this time we get a failure. If you can check, we get a failure status here, because routers are configured for their networks and their neighboring routers, but not for their neighbors of their neighbors. Okay, so router cannot interact with network connected to their neighboring routers and also other router connected to their neighboring routers. For that you need to define the routing. So let's just quickly see the steps of the routing with OSPF protocol. So here with OSPF protocol, we will be configuring router one by one. So for router 0, as we are considering only one area 0, we have to see the direct connections, means where the router is directly connected. So the router is directly connected to area 0 or network 40 and network 10. Okay, so two networks are in direct contact. Two networks are in direct contact with the router 0, 10 and 40. So now we need to make the connections for these two directly connected networks, means we need to define the connect or route for these two directly connected networks. Now for this you need to write the command in global configuration mode, means open the router in command line interface and then you need to enter to the global configuration mode, and for that the command is enable. Firstly you need to write enable or en, you can write en as well. So either abbreviation or full form, both will work. So after this enable command you will enter the you will be writing the command conft or config terminal or configure terminal, you can write in any form. After this you will enter, when you press enter you will enter the global configuration mode, and if you are in any other mode, means if you are in sub configuration mode, then you need to come back to the global configuration mode by writing the exit command. We will see. You will be writing the exit command to come back to the global configuration mode. Okay, so that you have to check. If you are in user execution mode, then you will be starting with enable command. If you are in sub configuration mode, then you need to exit from that mode to the global configuration mode. If you are confused about these commands, then you can see another video where we have discussed the commands in detail. So for now, with global configuration mode, we will be writing the command. This is the prompt for the global configuration mode. Now you need to write the command router OSPF 1. Here this 1 indicates the process ID. This is the process ID. This process ID means you are writing the commands for this router with the ID 1, means this one ID is assigned to this router for the following commands, means whatever you are writing for OSPF, those commands are assigned with the ID that is 1, okay, for this router. Now the first command that we want to run, after writing router OSPF 1, you will get this type of prompt. Okay, this will be the prompt. Then you will be writing the command network, and now direct connect. For direct connection we have two networks. So first network is 10. Then we will be writing the wildcard mask. Okay, not the subnet mask. Subnet mask we had written for the network configuration. So here we will be writing the wildcard mask, and now the area is 0. Area will be 0 for all the cases. Wildcard mask will be the same for all cases because we are using class A addressing throughout, and we just need to change the network for every router. Okay, so just keep in mind the command will be same, we just need to change the network. So here the second command that we need to run is network 40 and the same wildcard mask, and area is 0. Okay, so the configuration for OSPF with router 0 is done. So let's just quickly configure the router, then we will discuss the command for router 1. Open the router, go to CLI command line interface mode, and this time as we are in sub configuration mode, we need to exit. Now router OSPF 1, okay, router, as it is first router labeled as router 0, I am assigning it the process ID 1 that we discussed. Just enter. Now network 10.0.0.0. So this is the first network. Now wildcard mask, area for area 0. So area is 0. So we are just pressing enter. The command is executed. You may get the status loading is done, etc. Okay. So for the second repeat command, just press the arrow up arrow button for the second network. This time network is 40, belongs to the same area. We just change the network ID here and done. Okay. So these two commands are for the first router as it is directly connected to two networks only. Okay. So let's quickly see the commands for the next router. For the next router, as it is directly connected to network 20, 40 and 50. So this is the first connection, this is second connection, this 50 is the second connection, and this is your third connection for network 20, and all the networks belongs to area 0. Okay, so we have 3 connections, so we need to define 3 commands for this router, but this time we will be using process ID as 2. Process ID as 2. Process ID. Okay, because we are writing the commands for another router and assigning it the ID 2. You may use any ID up to 65535. So I am using the ID 2 for this router 1. Okay, so now we need to write the commands 3 times for 3 networks, all for area 0. For network 20, wildcard mask and area is 0. Next we will be writing for the network 40 with the wildcard mask as the same for class A addressing and area is 0, and third command will be for the network 50 with the wildcard mask 0.255 to 55.255 and area is 0. So this is the router 2's configuration. So let's just quickly configure the router 1. That is actually a router 2 but labeled as router 1. This time for router command I am providing the process ID as 2. Network is 20.0.0. Area is 0. Okay, done. Repeat the command for network 40. Repeat the command for network 50. Done. So you can also as we can see, we got the message as loading is done. You can also copy the commands by this button, copy, and router 1 or router labeled 1, the connection is done. Now for the third router we have to use a similar pattern, means as it is directly connected to two networks 50 and 30. So we will be writing the commands for these two networks. This time I will be providing the ID as 3. Okay, you just need to change the OSPF ID for the router 2, that is your third router of the network. So I am providing it ID 3 and the commands for network 50 and 30 with the wildcard marks for the same area 0. Okay, so let's just quickly configure the router. So for third router, go to command line interface mode, OSPF 3, and as I had copied the command, so I am just pasting it. It is connected to network 50 with area 0. Same command will work. Now loading is done. Now change the network to 30. Another network that we want to configure is, as it is connected to 50 and 30. So repeat the command for network 30 and done. So the connection are complete. means routers are configured for the routing protocol. This with OSPF ID1, this is OSPF ID2, and this is OSPF ID3. So let's just check by sending the packet data unit from router 0 to router 2, and we got the success. That means our routers are configured for their neighbors of their neighbors. Okay, so if the router are connected, the connected networks would also be able to communicate. So let's try sending something from first network's host to third network's host, and we got the success. From third network host to first network host, and we got the success, right? So here the connections are okay with OSPF router for area 0. If you may get the failure for the first time while trying to send a packet data unit, so you can try second time. If you again get the failure, that means your connections are not right. You may have provided some wrong IP addresses, or some gateways are provided incorrectly. So you need to check for every connections, okay, and rerun the commands every time. You can change you can also rerun the commands for the routers if you found any error. So till then, so thank you for this video. Till then, bye, and in next video you will see the routing configuration for networks with area 2 and area 3. The link is given in the description box. You can have a look. Bye.